All people are joined.
Yes, sir, joining,
Yes, sir.
sir.
Everyone has joined. We are actually live streaming it, so it's taking
It's taking
we are
time.
doing it, sir. We are live streaming it.
So
The show. That's why we
should
are
I
doing it.
wait now some more time or
Yes, sir.
No, sir, we will
Just two
start.
minutes, sir.
We will start now, sir.
I can start?
Wait, sir, wait, sir. Good afternoon, everyone. Sometimes we have to go up really high to understand how small we really are. I am Sai Madhuri, welcoming you all to the 60th episode of our weekend creative session. Before starting today's session, let me give you a brief introduction about our creative. Creative means creativity and activeness. To be active, we should be creative. And creativity is the mother of activeness. Sharing of knowledge doubles our knowledge. Hence, our tagline is Knowledge Square. Creative is a platform where we are introducing non syllabus, non academic, and non textual information to the curious people who are eagerly waiting to gain knowledge. We are organizing weekend sessions on Saturday evenings in Zoom platform and live streaming in our YouTube channel Creative GBD by inviting subject experts who share their work experience with our participants. We thank all the resource persons for engaging creative sessions with their knowledge. Today's talk is about the Space Odyssey of India by Dr. P.V. Venkatakrishnan, sir. Sir is retired distinguished scientist, director, CBPO, ISRO headquarters. On behalf of all the participants and creative team, I heartily welcome you to the creative session, sir. Let us know more about our today's speaker. Mr. Panindra, creative volunteer, is with us to give a brief introduction about today's speaker. Over to Panindra.
Thank you, Madhuri. Good afternoon, everyone. I am Panindra of a Creative Team Volunteer. I welcome Dr. P. Venkatakrishnan, Creative members, volunteers, and audiences to our 60th weekend talk. Today's talk is on the Space Odyssey of India, which will be delivered by Dr. PVV, retired as Distinguished Scientist, Director CBPO, ISRO Headquarters, and Professor Satish Dhawan, Scientist, ISRO Headquarters, Bengaluru. He is a native of Thrissur, Kerala, and born in the year 1961. He completed BTech Mechanical Engineering from Cochin University, PG Diploma in Production Management from Annamalai University, MTech in Production Engineering from IIT Madras, MBA from Annamalai University, and PhD in Mechanical Engineering in Welding of Aluminium Alloys in 2005 from IIT Madras. He started his journey in ISRO from 1983 after working as a mechanical and material entity in the Vikram Sarabhai Space Center. In 2002, he worked as Deputy Project Director for the Material and Manufacturing in GSLV Mark III project at VSSC. From 2010, he started working as Deputy Director in Liquid Propulsion System Center, ISRO Trivandrum. From 2015, worked as leading materials and mechanical entity of VSS on as its Deputy Director. In 2016, he became the Director of IPRC Mahendragiri, and in 2017 he became the Associate Director VSS-C Trivandrum. In 2013 he became the Director Capacity Building Program Office, which is also known as CBPO, ISRO Headquarters Bangalore. From 2021 to 2022 he worked as a Professor Satish Dhawan Scientist at ISRO Headquarters Bangalore. He has got 38 years of experience in the aerospace materials and manufacturing field, specialized in the area of industry interface and development, national capacity building, academic interface. He has taken some important initiatives as the founding director at the CBPO in ISRO headquarters. Here are some of the awards and recognitions he got. He got ISRO Individual Merit Award for Excellency for the year 2011, ISRO Performance Excellence Award for the year 2016, ISRO Team Excellence Award in 2010, in which he worked as a member for the realization of L110 stage for GSLV Mark III, and ISRO Team Excellence Award for the year 2012, and for the ingestion of special copper alloy for cryogenic engines, ISRO Team Excellence Award again in 2015 for indigenous development of special titanium half alloy gas bottles for GSLV Mark III. For these two teams, he was the leader of the team. And he got a Lifetime Achievement Award from the Society of Aerospace Manufacturing Engineers and Lifetime Award from Indian Institute of Material Management. And he is a fellow of Institute of Engineering. He is a fellow of Indian Institute of Metals, fellow of Aeronautical Society of India. And he has more than 100 publications in national and international journals and conferences. And I welcome you, sir, to this weekend talk. Thank you. Now over to Madhuri.
Thank you, Panindra. It's our pleasure to have you with us today, sir. Now over to Venkatakrishnan, sir.
So,
Sir?
good evening to all of you. Hope my slides are visible and I'm audible clearly to all my friends, young friends. Okay.
Yes,
Is it
sir.
okay?
Sir,
Yeah.
sir, can you go for slideshow, sir?
Is it not coming?
Slideshow is not coming, sir.
I have gone for slideshow only. 1 minute.
No.
I have gone for slideshow only. Fully only I have gone. Yeah.
Now it is.
Fine.
Sir, now it is okay.
Fine. So this is my talk, the Space Odyssey of India, from the beginning to where right now we are now. I just take a flavor of just a fast forward of all these things in just 40-45 minutes. Okay. So this is the vision of our great founder, father of Indian space research in India. The original space program with Vikram A. Sarabhai, you all know that. And his famous statement quote, I'm just quoting here once again to see that how much of vision he had long back itself in 1958 and 60s, when we have not even thought of what is space. So he was such a visionary. There are some who question the relevance of space activities in a developing nation. To us, there is no ambiguity of purpose. We are convinced that if we are set to play a meaningful role in the community of nations, we should be second to none. It was very clear. The applications of advanced technologies to the real problems of man and society. We continue to do that right now also. Our priority and our all these things are still continuing revolving around how the common man can be benefited from space technology right now also. What all things we do right now. Okay. Now also the vision is very clear. So you can just see that in 1962, Indian community for space activities and research was started in COSPAR actually. And 1969 it was renamed as ISRO. 72 the Space Commission was formed and Department of Space was formed and formalized and structured and attached to Government of India through a Department of Space and through a secretary. Till then it was only ISRO. You can see that there are three committees, main committees. Inside Coordination Committee, Satellite Communication Program is done by this committee. Planning Committee on National Rural Resource Management System, Advisory Committee on Space Sciences. In fact, after that, now navigation also has come into picture. Earlier, it was only INSAT remote sensing and communication remote sensing. Now navigation also has come into picture. And apart from that, we got science missions, pure science mission like Aditya and all these things. So that is coming under Space Committee for Advisory Committee of Space Sciences. So we got a very structured way of working. How would it work? I'm just taking through the framework. Then just a minute. I'll go back. Yeah. So you can see then how we were then actually, how we are right now. I'm just taking a slide. We were carrying the small rockets in the cycle. It's a famous picture. You all know that. In the Apple program in the villages of India, you can see that how many people were watching it through the direct satellite instructional television experiment program. We call it SITE. Through the Apple, whatever we have launched long back in the rural villages, direct connectivity was tested. Then you can see that a mobile launch pedestal, how we are carrying the rockets to Tumba Ikator rocket launching station. And one more famous picture is that in Bulakart, you can see that our INSAT is being transported. You can see Abdul Kalam sir also working with the small rocket on the left side long back when he was in the formative years of ISRO. Right now, you can see the Chandrayaan, how the picture taken through our orbiter of the moon. And we have the other Mark III and other things, and what all picture we are getting through remote sensing or antenna and ground support systems. So you can see the grade of growth what we have achieved in 65 years. Evolution of the space program. You can just see humble beginnings in 60s and 80s up to 60s and 80s. Then there was a measured expansion up to 2000. Very measured expansion with the limited resource what we had with our country, and sustained growth. The growth has to be sustained. That is what has happened in 2020. Now, this was called Space 1.0. Then comes a rapid acceleration beyond 2020. We want to accelerate further. So we have gone for Space 2.0 with space reforms opening out of the our Isro's facilities to private and other people outside to attract more people into this business. And we have got more players right now. Apart from Isro, a lot of private players are also opening to see that how best we can accelerate in the activity further beyond. Otherwise, no, we'll be having a resource crunch for the activities what right now exactly, because very capital expensive programs. All these space programs are you all aware. PSLV cost you 200 crores. Another satellite will cost you another 400 crores. Put together a mission will cost you 600 crores. Our program for our Gaganyaan is around 19,800 crores. So this kind of money you can't find out from a country like India, where we have got a lot of priorities otherwise to be spent. So we need to see that how best to sustain both our developmental activities for other sectors also, as well as our space development also. So we need to open out a little bit. That's what we have done in Space 2.0. The humble beginnings, I'll just go through a simple slide, whatever I told in the last slide. The Sarabhai's vision, second to none, was given the priority. Initiated clusters, Ahmedabad payload, Ahmedabad satellite application center, we had payload electronics and physics coming there. Trivandrum sounding rocket and solid propellants were coming there. Sriharikota was the launch site. A unique management style, bring together talented individuals, let evolve. See, talented individuals all over the world was collected by Sarabhai, and they all brought back to India, and we were given they were given a free hand to evolve their ideas and research. Leverage domain-specific international expertise. He was also getting a lot of connectivity. He was having a lot of connections with the international community of space, and he was also deriving a lot of knowledge and benefit out of them also, but yet rooted in India. That is a speciality of our Sarabhai. Then after that, when you all know that what happened at the young age, at the age of 51, he passed away, and unfortunately, without to the son of everybody. And suddenly, Professor Dhawan has to take over, and Dhawan actually structured ISRO to somewhat, the kind of structure and whatever review mechanism, whatever divisions and structures and what we are having right now, he had actually structured really. So shaped and structured the space program, institutional mechanism, Department of Space and Space Commission, the indigenous launch vehicles like SLV and SLV3 and ASLV was, SLV3 was the first launch vehicle ever we had tested with the 3 solid stages, and ASLV was with the strap-ons, 2 strap-ons added, and closed loop guidance also coming into picture. So these were technologies extra tested in ASLV than SLV. These two are actually developmental vehicles. Actually, we are only having 40 kg payload in the first SLV3 and 150 Rohini stretch series in the ASLV. So we were not having much of aims and objectives in that. We wanted to see that one satellite is launched in the low Earth orbit and we are able to sustain it. So that was the idea. So we could achieve it. And then came the PSLV, which is the workhorse of ISRO right now, also with 6 augmented six strap-ons rather than 2 strap-ons in ASLV, and we had a closed loop guidance. And the 3rd stage was liquid stage rather than all solid stages. So, and 4th stage also was a liquid stage. So this is the two important changes what happened in PSLV, and PSLV continues to be our workhorse right now, also going for LEO mission, Sun Synchronous mission, GTO, GSO, everywhere, and it has gone to Chandrayaan also. We have so a vehicle which is such a multi-purpose vehicle we have never seen in any other country actually. So building blocks for higher capacity launch vehicles, mechanisms for result-oriented space programs, NNRMS and ADCOS, all these structures were made by Professor Dhawan. Industrial interface and partnerships were forged out. Then came the measured expansion phase, 1980s to 2000. Actually we have joined actually ISRO in 1983. Myself and my own age group people joined long back in 1980s and 83, 84, 85 and all through those period. And we all retired right now. We are seeing the expansion, real expansion of ISRO phase. We are all there. We are happy to be part of all these expansion activities, what has happened in the building phase of ISRO. Building on solid foundation, liquid and cryogenic propulsion development was done during this period. New centers across the nation was built up. Perfecting the workforce, PSLV happened during this period. IRS, Indian Remote Sensing Program started. Then INSAT program also started during this period. Then 2000 to 2020, as I told some time back, growing in stature, operationalizing 3 indigenous developed launch vehicles. All the PSLV, GSLV Mark II and Mark III was operationalized. Developmental phase was over and we have gone to operational phase. Mastering the cryogenic engines, interplanetary missions like Chandrayaan, Mangalyaan were accomplished during this period. Science mission like AstroSat, commercializing the launches and going for Antrix first, and then now NSIL, no Space India Limited, and we are getting launches from outside our country also. Other countries are coming to India for launching the satellites, and we're getting a lot of revenue out of this right now. And navigation constellation, NAVIC series also started actually. Navigation through Indian constellation, that's called NAVIC. So navigation satellite also started during this period. So we are having all the 3 segments right now: remote sensing, the eye in the sky, the communication, connecting all through, including our remote, whatever mobile you are having through communication satellites, and NAVIC, the GPS system what you are using in your mobile as well as in your cars and other things also. GPS system all are developed now. You know how handy all these things are, how it is helping you in your real life today. I don't have to elaborate that, because you are using it day and night, and you are exactly deriving the benefit out of that. The GSAT series also, apart from INSAT series, now we have got GSAT series. INSAT series were launched from area and outside. Actually, GSAT series were launched through our satellites, GSLV Mark II and Mark III, and PSLV also has gone for communication satellites in the beginning before the GSLV was actually operationalized. We have used PSLV also for our geostationary missions. Then 2 striking features of Indian space program, as all you know, that self-reliance. That is one thing we are given maximum priority and importance. We always see that how we are not importing much, and we are always developing whatever we require for the Indian space program inside our country, taking our industrial growth also along with us. So industry and academia participation, infrastructure build-up, developing critical technologies in India itself in expertise and knowledge management. And apart from that, we are more actually concentrating on societal applications than competing with other nations or any of our things actually. Our priorities are very clear: development of our nation. You all know that how space has really contributed to development of our nation in connectivity, in railway booking, in your airline booking or your bus booking, whatever you are doing down through internet and whatever, and working from home, your online education, telemedicine, everywhere now space is playing an important role now. You all know that how much we have helped the country to see that what all areas where we can really leapfrog using the space technology. So today, if space is not there, there's no business at all. Everything will be affected. That's the idea. That's the kind of importance what space technology is having in our life today. The backbone for life today is the space. Equal focus on urban rural sectors. We are given equal importance for ATMs. ATMs are all connected through space only, and even in remote villages we are having ATMs now. So these are all important things what we are right now contributing through space technology. Optimum use of natural resources, efficient, effective, and low cost. That's the objective and societal application what we are having. You can see the Indian space program, how it is structured. Academia industry interfaces are there, and national commercial student, national commercial and launch vehicle, how they're connected actually, and student satellites are there, student launch vehicles are there, national launch vehicles are there, commercial launch vehicles are there. You can see spacecraft also, its observation satellites are there, satellite positioning system, communication, interplanetary, space science, and re-entry and return. All these things are very, very important. Ground services, e-governance, and technology spin-offs are there. I will go through all these things in 2 slides in each one of these slides, which is going to come right now. Socio-economic security, disaster management, sustainable development goals are there for of the government, that also we are accomplishing. And e-governance, we are playing an important role in e-governance. All the applications for your whatever your driving license or whatever your policies, everything is through now online. So there's a lot of cost reduction, infrastructure reduction. There is a fastness in action. All this, and decision making is very corruption is very less, all because of all these things. All these things we are contributing in an indirect fashion. Innovative management structure, we can see how our management structure, innovative, it's a matrix management, task integrated, headed by project director, and it's a matrix management. Matrix management means actually one person will be reporting to many people in many areas. One person I will be working for PSLV and GSLV Mark III also. I'll be reporting to 3 project directors for each different project as it requires. It's called matrix management. It's an innovative way of doing things. Maximum use of the human resources is achieved through this particular management system. Selection of right people for right task. Project director had ultimate say and responsible for achieving the milestones. And clarity objectives. Very good clarity objectives. What need to be achieved in what time frame. Everything is well defined. Dedication, commitment. You all know that what way we are all working. Actually, the sincerity and commitment, whatever we are having right now, and the kind of dedication it's called Isro culture actually. The rigorous review mechanism what we are having. We got a lot of follow-up and review mechanisms to see that everything is done meticulously. All seniors will participate in all reviews, apart from juniors also. VSSC is one center classical example of all these management style, whatever right now I told you. The management of launch vehicle projects, state-of-the-art facilities, you can just see that. How many wings are there? Aeronautics is interdisciplinary nature, and we work hand in hand, working with seamlessly integrating all these different divisions of engineering and science. Avionics, navigation, guidance, control, all of them are integrated together. And you can see the instrumentation, integration, checkout, all are integrated in a seamless manner to see how to achieve perfectly the goals what we have set. Supported by industries, research labs, establishments, and academic institutes, also from outside. Okay. This is the spread of ISRO now across the country. I don't put in space, which has recently got in right now. In space also has come right now. Apart from NSIL has been put here. You can see that NSIL is shown here. Apart from that, one more in space is coming here as a promotional and encouragement activity, separate board to see that how much private can be roped into the space activities using the ISRO facilities. Okay. 2 launch pads are there in Sriharikota. So first launch pad FLP and SLP has come in 2005. Third launch pad also coming up right now. Apart from one more launch pad is coming in Kuleshekharapatnam near Tuticorin right now. For that, we will be from there. We will be mainly launching SSLV, small satellite launch vehicles, which is a developmental small for 500 kg satellites right now happening. And the first flight, unfortunately, you all might have seen that as met with a small error in the last stage of the operation. We are correcting it, and soon we'll be coming back with the successful launch of SSLV, which will be again another workhorse for us in the years to come for small satellites to be launched in LEOs and LEO low Earth orbit. We have got a lot of demand for that from other countries. Once it is operational, we'll be getting a lot of launches from outside the country, generating a lot of revenue for our further activities. 53, 50, now it is 55 right now. This is not updated, actually slightly behind. Actually 55 successful flights were there for the PSLV so far, and GSLV 5 successful flights with the indigenous cryo stage. Apart from the cryo stage what we imported from Russia in the beginning. Mark III fully indigenous vehicle with the indigenous cryo stage. You can see 5 experiment missions are there. Space capsule recovery experiment, reusable launch vehicle technology demonstrator experiment, which started some time back. Crew module, atmospheric re-entry experiment, along with the experimental mission of the Mark III. The first experimental mission of the Mark III, we have done this particular experiment also. Scramjet engine technology, which is called air breathing engine, without your oxidizer propellant tank required. We will get the oxygen while ascent phase of the launch from the atmosphere itself. So lot of payload saving, for the inert mass saving will be there, which can be added to the payload once the your oxidizer tank is not there, only propellant tank is there. That much of weight is saved in the inert mass of the rocket, and it will be helping to the carrying more payload actually. So that is the air breathing. Air breathing means getting the oxygen oxidizer from the atmosphere itself by the ascent phase of the rocket. We don't carry separately an oxidizer. Only fuel will be there. Crew escape system and launch pad, that also was tested recently for the Gaganyaan mission. Apart from that, satellite, if you see 112 satellites are there, including remote sensing, communication, navigation, space science put together. So 79 launch vehicle missions and 112 satellites so far, and 342 satellites of 33 countries. It's a phenomenal feat what we have achieved so far actually. And space technology applications, countless applications across the country, aiding all sectors of business and our activities. And we have become the nerve center of activities all across India. Vision, harness, see human space, Indian space program, the dimensions I'm telling you, space transportation, we got separate PSLV, GSLV and reusable launch vehicle. Reusable launch vehicle will reduce the cost of the mission like anything. We can reuse the launch vehicle instead of expendable launch vehicle. One-time use launch vehicles are going to cost you more. So reusable launch vehicle technology, what we are right now demonstrating, the second stage is right now, we are into that second stage also. Dropping through helicopter and landing it in the land. First one has landed in the sea in Bay of Bengal. After that, now we are trying to land it in the land itself in Chitradurga near the North Karnataka. After that, we'll be having ascent and descent and now guided landing. Now it is unguided landing actually. After that, we'll be having guided landing, controlled landing. After that, reusable launch vehicle development will be over. We'll be starting using that. Once we are starting using that, refurbishing it around will be the repetitive costly coming for the launch. Otherwise, no, the launch of launch vehicle cost will come down like anything, and access to space will be very much economical. And we're getting more launches from outside, and our own launches also will become more economical and more affordable. And we got another fourth vertical capacity building right now. I was heading that. It's a recently formed wing and fourth vertical of Isro, which I was the founding director, Human Resource Development, Indigenization, Technical Infrastructure, International Cooperation, Industry, Academy, Outreach. All these things are coming under this, including human resource development also is coming under this. So space infrastructure is another one. What is already we have launched all the satellites are to be preserved and to be secured. You know, the security nowadays of all spaces is an important task. Other countries can attack our satellites, so we need to safeguard our assets on space. That also is an important job. Now, space situational awareness is another branch coming up, and we got another one more small separate wing started for that right now. Apart from the security of our satellites on top, and our ground station also need to be safeguarded from the attack of other countries or anybody else otherwise. Space applications and is another thing like SATCOM and navigation, and we need to see that how best our space science technology what we have developed is fully put into operational and made use for the common man of India. That is another part of space applications also we are into now. You know, 17 communication satellites, 18 remote sensing satellites, 8 navigation satellites, and 2. And these are the upcoming. This one we are having. Okay. This is the one what we just now had actually. After that, the recent ones, the split up of whatever I told earlier, and space technology with the sustainable development goals. You know, space, socio-economic security, food, water, energy. You might wonder how it is connected. It's all interconnected actually. Good water. We can just have a kind of a survey and find out exactly what is the kind of nature of water we are having, how to purify it, how to secure. So the data collection is an important thing now. Now you know how much important the big data analytics and all these things are coming up right now in a big way. All these things are going to aid. Once the data is collected, how to transform the data into information and use the information to enhance our knowledge and make it use to the country. So all are happening through big data analytics and computers. So all these things, data is required that is generated through space and our satellites only. Socio-economic security, sustainable development, impact assessment, fragile coastal ecosystem, climate change impacts, urbanization, geosphere and biosphere, governance, planning, monitoring and evaluation, decision support systems in governance, and disaster risk management. You know, the kind of disaster nowadays, whatever we had long back is not happening nowadays. We have only 1 or 2 casualties right now in all our cyclones and other things. You know, when I was there, I remember more than 1 lakh people died in one of the cyclones in Andhra. So now we are having with all kind of disaster risk reduction, disaster management system. We are prepared for all these natural calamities, and we can early warning system we are having, and we can see that how to safeguard our assets as well as our life of our people. So, you have the configuration of the next one coming up, 2 S200 N1 and C25, 6 ton to GTO. A new vehicle which is
Sorry, sir.
It's okay, fine. So we have the new technologies coming up. You can see the payload, how much we are going to build up. We can go to 6 ton to GTO. with a heavy lift of vehicle, with semi-cryo engine and everything. So how to bring out the best. You can just see that I'm not going through elaborate. I'm only trying to see how much of development is happening in the launch vehicle side to see that larger payloads are put into orbit. Heavy lift of vehicle. That's what some time back I told the last slide. You can see that lift of mass will be 485. 5 to 15 ton to GTO will be the largest vehicle ever we have made. Our work is on right now. Apart from this, we are going to SSLV also, small. So both ends we are working actually to see that how to cater two segments separately. One is more for commercial. This one is HLV will make all our launches from our land itself. We will not be going to Ariane or ESA or any more of our larger 4 ton plus satellite launching. Will be doing everything from India itself. Okay. You can see the developmental. I'm not going to detail. It's a very detailed one actually. You can see semi-cryo engine once it is developed. SC is semi-cryo. SC what I put is semi-cryo. So apart from the stages, what right now we are having solid stages and cryogenic stages, semi-cryo and C25 will be augmented to C37 or C27. Some more propellant will be put into that, will become C25 or C27 or C35 even. We're developing that also. And you can see the kind of payload growing from 4.9 tons to 7.8, which modular construction. We can have each of the module combinations, permutation combination of all these stages can be put separately. We can have different launch vehicles with the same stages differently selected and joined together. So that is the idea. So modular construction and your modular vehicle will give you a lot of flexibility in the years to come. We can go up to 16.3 tons in future with HLV coming up with the two semi-cryo stages of 400 ton each and one more semi-cryo core and C21 cryogenic stage 27 ton on the top. It's three-stage vehicle. If the ultimate one will be aiming at with the modular construction, and that will be 16.3 tons up to, and LEO can go up to 41. Low Earth orbit can go up to 40 tons. You must imagine. So reusable launch vehicles, another one we are working right now. Sometime back I told we will be having the demonstrator mission with the helicopter dropping it. You can see that helicopter here dropping the vehicle with the unguided pathway in the Chitradurga. And after that, we'll be giving a guided descent also, and guided ascent and guided descent. With guided ascent and guided descent proven, we'll be having the full mission with us, and we'll be start using it. The features of small satellite launch vehicles, you can see that. 1 minute. That's what sometime back we launched, and we had the first mission, a small hitch, and there was a small failure in that we could not reach the desired orbit. Even though we could reach there, we could not place it in the desired orbit. 1 minute. Yeah. So we will correct it. We'll be correcting it and coming back again. This will be actually the launch time is only 3 days. It's like almost all our Uber taxi. You can just tell 3 days in advance, and you can book the launch, and you can launch it. And 500 kg can be put into low Earth orbit. The advantage of that very low cost mission. And once it is operationalized, we can make it hundreds and keep it ready for any launch anytime. And we got a second launch, another launch site also coming up, Pulachegarapattam near Tuticorin for this in Tamil Nadu, South Tamil Nadu. Yeah, this is another one. What we are working is the propellants. What we are using is not green propellant, not eco-friendly. This area also we are working now. I'm not going to give you detail because of paucity of time, and it's an elaborate subject in itself. So we need to go into that itself if you want really. I just want to mention that we are into this job. Ion propulsion is ionic propulsion. Electronic propulsion is one another one. For satellite propulsion, we are working on that electric propulsion. That also will actually the payload can be increased more because propellants, if not to be carried much in the satellites, you can carry more payloads, useful payloads like your camera or your transponders or your GPS or whatever you want further. So ionic propulsion will reduce the weight of the propulsion system. That also is another area what we are working on. It can be longer life for it can give you longer life for satellites also in the orbit. So this is the INSAT system. How many satellites are right now in place? You can see how many transponders are right now in place. You can see. Okay. How much of remote sensing satellites are in place right now? How much of what all things we are using it? OceanSat for ocean monitoring. So many things we are using: radiation budgeting, radio occultation, and we can use it for many purposes actually. ResourceSat is there. Weather and climate. And some of the future missions right now up to 2022 or 23 was planned some time back. Some of them are lagging behind little. Otherwise, we are in track actually. You can see HRSat, high resolution satellite also is there in picture. OceanSat, G1Sat, GISat also is there. Cartosat is for your no mapping. Okay. You can see other ones, scientific missions. You can see Chandrayaan 1, interplanetary missions. Chandrayaan 1, you all know that we have been successful. We went to the moon and moon impact probe was there. And Mars orbital mission, Mangalyaan, you are all well aware of that, how much successful. And first attempt itself, Astrosat is another one which we have done right now. And Chandrayaan 2, of course, you know that we missed it by a whisker the last minute. And Chandrayaan 3, we are going to repeat with a lot of changes now. I don't want to go in details of the Chandrayaan 2 mission, what has happened. And you're all aware that orbiter, lander, and rover were there. And finally, that Vikram could not land there only on just 2 kilometers away. We had crash landed actually. So Aditya L1 mission also we are planning right now, which is going near to the Langagre point, we call it. It's a advantage point. We can see all satellites, all planets from one point. So that point, if you can put a satellite, you can observe all the planets and you can see, you can study and you can study the sun also very close vicinity, wherever to the extent possible, where we can go and study the evolution and what is happening to the sun and other things also. Continuous study can be happen. So this is one of the science mission what we are contemplating. Chandrayaan 2, of course, Mark 3 has taken over majestically on July 22, 2019. You all know what happened. So how the Chandrayaan mission worked, Chandrayaan 2 mission escape velocity going out of the Earth's orbit and inserting into the moon's orbit and catching the moon's orbit. You can see that you caught the moon's orbit, everything. Finally, South Pole we are supposed to land here. You can see that what I'm showing here. But in just 2 kilometers away, we missed it by whisker. We are repeating the feat right now with a lot of changes. Gaganyaan is the another human space flight mission what we're attempting for three-member crew. 4 people are getting already recruited and they are undergoing training right now. Out of the 3 will be flying together in a crew module, spending 7 days in space and coming back. This will be marking history in Indian space program and the space tourism, space habitat. So many things can spring off from this kind of the kind of technology what we are going to develop will develop the industrial sector like anything in India. You can see that orbital module is going to the orbit, and re-entry will happen here. Aero braking is happening and coming and splashing down the sea and taking them back. 7 days by the time we'll be spending in 400-kilometer reorbit. 5 to 7 days in. You can see that this is a kind of a mission planning we are having. Sounding rockets, you can see sounding rockets are small rockets which is sent to the atmosphere for study the atmosphere and meteorology. And PS4, we are having an orbital platform now. The PS4 last stage of the rocket right now, after separating the satellite, is again spending some more time in the space. We are going to put more of experimental platform payloads into this particular PS4 platform and trying to make some more propellant to that and orbit that around the Earth for another couple of weeks, so that now we can conduct some microgravity experiments in that. So this is another orbital platform. Right now we are working, POEM, we call it a PS4 orbital mission experimental. So POEM we call it. We have got a lot of experiments now queued up through in space from academia as well as the research community in this platform for all the launches going to come right now from PSLV. You can see the array of rockets what we have developed, smaller ones to bigger ones. You can see all these things. ISRO's international cooperation, you can see how much countries, 230 agreements with 55 countries in 5 multinational bodies in observation, satellite communication, SatNav, TTC, exploration, space law, and capacity building. All these things we are having collaborations with 55 countries. You can see the realization of joint satellite missions, accommodation of payloads from other countries, ground station TTC, Brunei, Indonesia, and Mauritius. We are having cooperation, data sharing with Brazil, Europe, with a lot of other areas and segments. I'm just giving a flavor of exactly how much international cooperation what we are having. There's a training program for satellite making, capacity building happening here. Unnati, you can see that people from other countries also participate in these missions. The policy regulations, we are participating in advisory committees for policy regulations, international forums. And PSLV launches, you can see 342 satellites so far launched from 33 countries, including 190 from USA. You can see the countries participating for our launches from India. And the global reach of IRS data marketed through foreign stations and sellers. So many people are buying our data and using them for their use in the urban planning and other activities in their own countries. 2 satellite contracts from Europe and LMC EDAS, Austria. Building satellites also, we are having 2 satellites we are building for the foreign countries. And Exo World is one important mission right now we are having. It's a very 2025, very launch. We are having actually important launch what we are going to come in 2025, which will give an insight to almost all planets. How and the research through is called Exo World Planet, which will give you into insight into the kind of universe and ecosystem what we're having in space. We'll be having a huge study platform through this. So the largest science mission we'll be ever attempting in the couple of years to come. Recovery of reuse launch vehicles, you can see you can see the reuse of stages actually. The stages, whatever we have spent is now falling in sea. Instead of falling into sea, if you are able to reboost and to bring it back to Earth, we can reuse it. That is another way of bringing down the cost. That also we are attempting now for using the spent stages and refurbishing and reusing it again, so that now the cost of launch can be brought down. That also we are working on, apart from a reusable launch vehicle. So you can see this 225 agreements with 51 countries, multinational bodies, Isro, as well as we have got a road ahead. What is the road ahead? Actually, reducing the cost of access to space through RLV and other missions like air breathing missions. Augmenting the constellation of Earth observation through, you can see that kind of whatever. Building capabilities of exploring universe, Chandrayaan 2, Aditya L1, exoplanet, Venus, and Venus mission also is in the offing now. Pursuing India's human space program, Gaganyaan, sustaining and vibrant application program, touch everybody's life and everyday's life, and for sharing capabilities through international relations to other countries also to take. Our mission is Vasudhaiva Kudumbakam. The world is one family and one universe is one family. That's the concept we are having. To share all our knowledge with other countries also to see that everybody is uplifted and developing. So you can see that R&D endeavors, software, structural engineering, propulsion, mission design, manufacturing program, all aspects of your engineering or science you tell interdisciplinary, the rocket has got everything in that. So actively pursuing the technology transfer of all these technologies to industries also to take industries also along with us. So more than 300 technology we have transferred to the industry. There are a lot of spin-offs happening actually. There are a lot of society applications of our whatever we have developed for our rocket applications or our programs. You can see that Caspol, fire-resistant coating, which we are using in army for tanks and all. Lithium-ion cells are used in now in our electric automotives also. Polyurethane feet is there with our new material which is very lightweight, and silica aerogel is an insulating material which we use for our cryogenic stage insulation, which can be used for thermal wear in Siachen and other ways for our army also. Search and rescue beacon, which is used by our fishermen for distress alert transmitter, is another one which we are using in our fishing community when we go deep sea fishing. So all these things, prosthetic leg, and the LVAD, large left ventricular assist device, is a heart valve actually. We are trying to make it and give it to our people. Actually, it's 7 lakhs to 8 lakhs when you import. Now we are trying to get it for 70,000 rupees. So there are spin-offs happening to our society from the space technology and space applications. This is another slide on same thing, the fire hazard. You can see how much we are saving for through this fire-resistant material, chemical powder, and you can see all these are spin-off. Jaipur foot. This is from with our composites, what we have developed. A lot of MOUs are signed with other industries also in India. Clinical trials also we are into. We are trying to see that how best we can make use into the community directly. We are involving every phase and seeing that the common man is benefited directly. You can see the lithium-ion battery. we are now giving to Automatic Research Association of India and technology transfer. So for e-mobility and e-transportation. And BHEL is, we have given the technology transfer to BHEL. We are trying to make it in numbers now for our space purpose as well as automotive purpose. Caspol is a ceramic polyimide hybrid. I told some time back the tent material, which is a fire retardant material. PU foam, all these are all our spin-off technologies. What we have developed, technology what we have developed has been made to common for other use also. LVAD, sometime back I told how it is assisting the. You can see that this is also getting qualified in clinical trials around now. You can see. Can you imagine the world without satellites now? Telecom, banking, internet, GPS, TV, shipping. You can see weather. Mapping is there, mobile internet connectivity and business, all other things are. So this is the kind of impact what the space is making in your daily life, and all has happened through our work and our efforts. So famous Abdul Kalam, actually I was working with him during the formative years, during my initial periods. We are all born with a divine fire within us. All efforts should be to give wings to this fire and fill the world with glow of goodness. Each one of us to try for that. And his vision, if you're trying for that, we are achieving that, India will be second to none in the Committee of Nations, as Vikram Sarabhai has really dreamt. And we are all working towards that. And we see that you all join hands with us in the short future when you come out for working in various sectors. Even though we are not in Isro, outside Isro also you can contribute now. A lot of platforms are available for space activities. So let us join hands towards self-reliance of Indian space program. The tireless journey of pursuit of excellence continues through generations. Okay. Thank you so much.
Nice talk, sir. Thank you, sir. The important thing is that not to stop questioning. So let's ask some question to sir. Is anybody there to ask questions? Any questions?
Any questions are there from any of our rank colleagues? You can ask me so that I'll be able to answer.
Yes, you can raise your hand.
Sir, I have a question, sir. I have few questions.
Yeah.
Sir, actually, I've heard about Wolverine material. They said that Wolverine material, if something ruptures from that material, it actually, attach itself back. Now, do we have the technology in India? And if we have the technology, can we use it to build? Can we use it in space
It's
travel?
not rupturing. You meant rupturing, or it is a docking or rupturing? What do you mean?
No, sir, it's like a sheet. It's like an aluminum sheet, and if something, the space debris hit it, and when it ruptures, it'll actually join, itself. Because of the, they said it's because of some high reaction.
We are working on shape memory alloys. It will take its own shape of earlier shape after some time when something's happened to that. So that is one thing what we are working on. But this rupturing and again joining back automatically, you mean?
Yes, sir. Automatically.
Should be an extension of shape memory alloy. What people are talking about. I think that will be also an end use of that shape memory, and once you develop it, we are into shape memory alloys. We are doing some research on that.
Okay, sir. And I have another question. In space, we have around, we are very, the temperature is very near to absolute zero, right?
Yeah.
Yeah. So, does the conductors in space become superconductors, and can we make use of those superconductors?
No, we are aware that it becomes superconductor and very usable, but we have not conducted any experiment in space so far on this ground so far, because in the years to come now, such kind of experiments will be done by more of academic community in the platforms of PS4. But because we have been always concentrating on how to give the maximum to the country for our things. So now with the opening out of space and more people coming out and working on experimental missions, we'll be having more such experiments, and we are able to come out with more relevant data and results for such kind of questions. Because definitely we know, but we can prove it by once doing it. So I think in the couple of years to come now, more experiments will be conducted in space in our PS4 platforms, and we'll be getting more results and data regarding this.
Okay, sir. And sir, you told about cryogenic engines. You said something C3 and C25. Yeah, sir. I didn't understand. You said we have C25. We'll also move towards C35. I didn't understand that, sir.
C25 is nothing but 25-ton engine, which we have developed for Mark 3. C25 is a stage. 25 stage means 25-ton propellant is there in the stage. Okay.
Okay.
So propellant tanks put together 25-ton stage, 25-ton propellant is there. So we are now trying to expand. It can be expandable now itself to 27. 27 easily we can do it because now only we are loading 25 only in the propellant tank, which can otherwise load 27. So easily we can go 27. And we are when we are going to HLV, we'll be going to C35 also. To see that more power is generated, okay, in each stage to reach to that kind of a payload of 6 ton plus in G-orbit or 40 tons in LEO.
Okay. Sir, this question is
massive power is required for all these things. Okay, huge power is required.
okay. Sir, my next question is related to you. So you actually joined to ISRO in 1983, right, sir? Yeah. So and you did your masters after that, right?
Everything after you see after my BTech is done along with my career in ISRO.
Were you working in ISRO and then you were doing simultaneously all the
working and doing both? You have to run that extra mile.
Okay, sir.
Okay, but there are opportunities given to you by ISRO. They'll give you 4 or 5 months study leave and all these things in between. You can go to IIT and do the study and do your all experimental project work in ISRO itself. That's how we can do things. Okay.
Okay, sir. Thank you, sir.
Okay.
Hello, sir.
Yeah, please.
Sir, are there any works with astrobiology, sir, in ISRO, sir? Biology.
Astrobiology, two startups have come up now.
Yes.
Two startups have come up actually. Now they are working, and I am also they are also dialoguing with me also in certain areas of real work what is to be carried out in our space activity. So we are into that now. Now slowly these kind of other activities also will start more in space because now we are opened out to outside. Otherwise, no, we will not be able to concentrate on all. See, the space, the impact of space is too much in all other areas also. As technology enabler, ISRO cannot concentrate on all these things. So unless we have done the space 2.0 and opening right now, it's the right step what government has done. We can't achieve all these kind of objectives in the near future. It will take more time for ISRO alone to do it.
Okay, sir. Okay, sir. Thank you, sir. Thank you.
Yeah.
Any questions?
Hello.
Yeah.
Sir, this is Vijayshri, and it was a very nice presentation, sir, covering from all the areas in ISRO. Just one thing, sir, where we have not yet attempted is the whatever debris we are creating in the space. Like we are launching so many satellites, but then once the EOL happened, that is the end of life of that particular satellite. It is either deorbited and few of them are done, and then otherwise they're going in the parking orbit above, but then they are still continuing to be in some or the other orbit and cause problems. So we are looking into any of this law, how to destroy them, how exactly you have to get rid of that debris there in the space.
Getting rid of the debris is not possible because debris will be there in space and it won't be having any, it won't re-enter into atmosphere and causing you any kind of security threat to our living beings in the country or in the earth.
Yeah. Yes.
But what we are now doing is we are keeping some propellant in the satellite. We are not fully utilizing it and using it for our own life. Before life, we are all supposed to keep as per the law, international law now. Some propellant to reboost it and remove it to a graveyard orbit. It's an upper orbit actually, slightly upper level orbit, a graveyard orbit.
Right.
You continue to revolve around the Earth for a long time without re-entering the Earth. So that is what we are doing. But your question is valid. In the years to come, if you again overpopulate this graveyard orbit, also what will happen?
Exactly.
A lot of work is going on
in
this direction. We are all party to it. You have had a UN dialogue. Everything is going into that. So all these things are expected in the near future to come, and a lot of regulations and guidelines also will be formulated and will be coming through with some kind of a regulatory guidelines as well as technical guidelines also for all these things to come. Otherwise, no, whatever you are doing for the good should not become bad for the human being. Okay.
True. See that like now we are facing the same problem on Earth. So after sometimes we will
No, that
have to see. Yeah.
to come to that level, lot of things has to go on. The number of what has gone to orbit so far is very less. But we are aware of this kind of danger, and a lot of people are working on that. So the space situational awareness branch, what we have created right now, another vertical in Isro, takes care of see that they are not impacting to each other. That one of them, and even some of our missions you might have observed will relate by 1 or 2 seconds, 1 or 2 minutes sometimes, or seconds before launch.
True.
Because it should not collide with another orbit. Already the orbit will be
Right.
coming through that. So all these things now we are aware where it is, what it is doing, everything we are aware. We can deboost it and we can take it to graveyard orbit, all these things. But graveyard orbit, overpopulation also, we can give another graveyard orbit also after some time. But all these things we need to address, and we have got regulatory systems now. Just like that, we can't launch. We have to take the orbital permission, everything in the future. So there are some framework coming up, and this will not be a danger in future. That much I can promise you. That
Yes.
efforts are taken to see that the systems what we put in orbit should be only helping us, which not be put into trouble. That much of definitely we are taking action for that also. The international community, not we alone. Okay.
Yes. True, sir. Yeah. Thank you, sir.
Sir, I have a question regarding that, sir. Parking orbit. Yeah, so instead of placing the the used or the not working satellites into a parking orbit, can we move it towards the sun and give it a boost from the engine so that it just keep moving towards the sun, and when it goes near, it will just turn into ashes or something like that.
To bring it to near to sun, to make it to burn or something, how much close you have to go to sun, near to sun. You're aware of it. Sun is far away. The far what I'm told to tell is very far. Okay. So the kind of propellant what you want to use actually to bring it to that level is very costly. That much of propellant, if you want to really put into the satellite, no payload can be there. Then no useful purpose will be there.
Okay, sir. Okay, sir.
You got it?
Yes, sir. I mean, the thing is,
it's a trade-off. What we are doing is a trade-off. See, we need to put maximum payload, useful payload, like your camera or transponder or navigation system or into the right. That is what is really going to make help users useful for us. Propellant should be less. That's what we are going to ionic propulsion all. So if you want any other activity to be done, including deorbit and putting it in the graveyard orbit, also you have to keep some propellant that we are doing at the cost of the payloads actually and usability of satellites. Okay. So it's a trade-off actually. So we need to compromise on certain things when the purpose of launching satellite will be lost then.
Okay, sir.
Any questions?
Hello.
Okay, if there are no questions, then can we end?
Sir, I have.
Yeah, please.
Sir, does Mars contain water before, sir? Does Mars contain before water?
Pardon?
Does Mars contain before water?
Water is there in Mars, you are asking?
Yes, sir.
See, Mars, why people are going to, out of nine planets, why people are concentrating on Mars and going near to Mars always? You must be wondering, no, is it not? Because
Yes,
Moon is a satellite actually. The other planet out of 9, Pluto is now they are contending it's not a planet now. Okay, whatever way you are telling 9 or 8. Why we are all going towards Mars? That's a question always people wonder. Why we are going to Mars, not Jupiter, not Venus or anything? Because all other scientists have told once long back itself there was an evidence of existence of life in Mars long back.
Okay.
If there was life in Mars, then exactly what happened to that life? Why that perished? Why it became extinct? What happened to the life? Or if life is there now also in Mars, we don't know. We don't know.
Can we colonize in future, sir?
No, that's what. So we wanted to know exactly whether life is there in Mars Okay, if there's no life in Mars right now, was there life in Mars? What happened to that life? Why they became extinct? What happened to them? That should not happen to again for all of us in Earth also in future. So we need to study all these things. To study that only, we are concentrating more missions near to Mars. So first landing, we have to do it in Moon now. After that only, we can, same thing we can repeat a little far away in another planet like Mars, and we can land there and see, conduct studies. So we are orbited near to the Mars right now. But landing now we are trying to do on a satellite very near to Earth on Moon right now. Once we are able to soft land on satellite on Moon, we can repeat that mission with the next mission on Mars also. We can put some satellite which can land in Mars also with a soft landing, and we can see whether once we are the country which has very clearly told the world for the first time that there is evidence of water in Moon. Everybody is accepted, including NASA. Okay, so whether if you are able to get such kind of an evidence there, water or air, something is there of something of useful for life existence or sustenance in Mars. If you are able to bring out that, I think that will be useful knowledge to the community of people. And of course, colonizing is all, we can always dream all these things is far away, but definitely, the kind of epidemic or pandemic what has happened right now, such kind of pandemics comes in Earth once for all. Now sometimes everybody will perish. You never expected what kind of pandemic came, and now people are telling it is gone. It is not gone out. People are also telling that also. So we need to see what happens to the life sometimes. No, if you want to go to escape and go to another planet or anywhere to see that these kind of viruses are not there, I'm not joking. The space tourism is coming up, space travel is coming up in a big way. If you are able to go to another planet and escape, you can sustain your life and you continue living there happily without any problem. These are all going to be viable solutions for all these kind of pandemics in future also. So all these things are questions and question marks for future for us to study for different communities and different sectors, like people like you or all youngsters. You have to come out with solutions for all these kind of things in near future. Definitely, we don't know much about Mars. To study that only, we are going near that.
Okay, sir.
Yes. Thank you, sir. Sir, one more question I have, sir.
Yeah.
Last question, I think. Sir, we launched satellites for various purposes, for communication, for weather forecasting, for various purposes. What is the main aim of launching a satellite, sir? Main aim?
No, it depends on what kind of mission, what kind of satellite it is. The satellite is only a kind of a structural body with propulsion system, everything inside that. It will go and revolve around the Earth. But what payload you are putting inside, useful payload, what you are putting inside. If it is a camera, it's a remote sensing, you can observe and you can see and take pictures. If it's a transponder, you can have communications. If you're having a GPS there inside that navigation system, you can have from there, you can get signals for GPS, whatever you're using for your GPS system in your mobile or in your automobile. So it all depends upon what kind of payload you're putting into, useful payload you're putting in. That defines the purpose of satellite. For that purpose only we are putting astrosat. If you're putting, it's for astrology. Resource sat if you're putting for resource measuring and other things. Ocean sat if you're putting for ocean study. So the payload what we are putting will be in such a way that it will be taking images of water. Water, if you take image, it will be infrared image to take water underneath, water underwater also. And what is the kind of resources? What kind of resources? Fish, potential fish zones. PFZ we are having more fishes available for people to go and fish them. The fishermen can go to that area and fish them. So every day they will give a range where the more fish is available, that to that direction you can go, and you don't waste your time then. So it depends on what purpose you are launching. EduSat was put for education. Then it was used for your Victor channel. Now also we are using EduSat only. Okay. So it all depends on what purpose you are launching. The purpose is well defined before launch, and that kind of a payload will put in satellite, and satellite will become useful for that purpose.
Okay, sir. Thank you, sir.
Orbit also will be sent to suit to that requirement.
Okay, sir.
Remote sensing will be close to Earth, LEO satellite. No, because then only we can see pictures very clearly. And resolution of camera is increasing, means you can get minute parts. Communication satellites will go far away, 36,000 kilometers, GT orbit. So it depends upon the orbit also what kind of use you are putting the satellites on.
Yes, sir. Thank you, sir. It was really a nice session, sir. Okay. It was interesting, sir. Thank you for your time, and thank you all the creative participants for your participation. Thank you, sir.
Thank you so much. All the very best for all of you. Okay, thank you so much.
Thank you so much, sir.